Good morning. This is Mr. Herman. The past couple of videos that we've looked at so far, we've been talking about recursive formulas. We talked about what they are, we talked about arithmetic recursive formulas and what they look like, as well as geometric recursive formulas. In this video, we're going to apply those to some simple problems where we're just looking at equations themselves. We're going to be using them to generate each of the terms in our sequence. Okay, so this is something we did with explicit formulas last week or earlier this week, where we just plugged in a value for n and we were able to get the term value. This time it's not as simple, okay, because we've got two parts in here that we have to worry about. Okay, so we're going to start here, and in this question we're asked for the first 5 terms of the sequence. We have to point out a couple important things. One, hopefully we recall, since this says A1 right here, this is our first term. Okay, so as we are writing out our first 5 terms, we'll call that part A, our first term will be negative 16. Okay, so we've got our first term in the books. Now we've got to see what is our pattern. Okay, now if you remember back to our formulas that we saw, I'll go ahead and pull that up for us. In arithmetic recursive formulas, we said we've got our first terms A1, and then we have, in this case, we have AN equals AN minus 1. Now as we come down here, AN equals AN minus 1 plus or minus D. And we said that D was that common difference. Okay, so in this case, take a look at our formula that we were given. D is negative 4. Okay, so this is our common difference. So our pattern will be minus 4 each time. Okay, so now we're working with some negatives here and we're subtracting from them. So each time we're going to get a bit smaller. We get more negative. So negative 16, we're going to subtract 4, get negative 20. Okay, so minus 4. Then we want to minus 4 again. We're going to have negative 24. Minus 4 again, negative 28. Okay, and if we do it one more time, we'll get that fifth term of minus 32. Okay, so that's what our first 5 terms are going to look like. Now part B is asking for the 8th term of the sequence. Now in order to find the 8th term, or A8, we have to know A8 minus 1, which would be A7. But here we just know A1, A2, A3, A4, and A5. We don't know A7. We need to find A6. We have to use A5. Okay? So we know that A5 equals negative 32. We're going to just keep using our pattern. A6 is negative 32 minus 4, which equals negative 36. A7, negative 36 minus 4 equals negative 40. And then A8 equals negative 40 minus 4 to equal negative 44. Okay, so that recursive formula isn't as easy to find a term that's way down the line. Okay, so if we had to find the 50th term, we'd have to find the 49 terms before it. Okay, so the recursive formulas are not that valuable when we're trying to find a term down the road. Now, if we're looking for a common difference in the first term, it tells us that very clearly in our equation. Okay, so we're going to usually use explicit formulas to find a term, but if we're looking for what's the pattern, which is the first term, we're going to turn to our recursive formulas. Okay, so let's take a look at our next problem here. We are given a sequence 256, 512, 1024, and 2048. Okay, now we would assume maybe it's arithmetic. Let's check if it's arithmetic. So we have 512 minus 256. That's going to give us 256. We check here, 1024 minus 512, that is going to give us a plus 512. This is not arithmetic. Let's check if it's geometric. Okay, so if we're going here, okay, so a bit small here, and try to squeeze it in, 512 divided by 256, that's going to be 2. If we're going from 512 to 1024, we've got 1024 over 512. That's going to be 2. Let's check it one more time just to make sure. 2048 over 1024 equals 2. There we go. There's our geometric sequence. So we have to now write a recursive formula for this sequence. Okay, so let's take a look. We want A1. Our A1, that's our first term. We're going to do this to D6. First term. And we'll go ahead and use AN equals AN minus 1. We can always start with this. Okay? Now, in this case, if we take a look, let's see if I can find here we are, on our common ratios in our geometric recursive. We're going to take our AN, those are AN minus 1, times or divided by R, our common ratio. Okay? So our common ratio in this case would be times 2, which we doubled. So what we can do is we can just put a dot and we multiply by 2. Okay? That's our common ratio. It's as simple as that. Okay? All we have to do is look at our pattern, find what was our first term, what was the pattern that we saw, and then apply that at the end. Either with a common ratio in a geometric sequence, times it or divide it. If it's a common difference in an arithmetic sequence, we'll add or subtract. Let's go ahead and move on to our last one. Look, so we've got A1 equals 8, AN plus 1 equals AN plus 13. It's going to work the same way. Okay? Now, we are writing the 5 terms, the first 5 terms, so we're going to start with that 8 there. And our pattern here, here's our first term, we'll label that. Pattern just tacked on right there. There's our common difference. So we're adding 13 each time. So plus 13, that's 21, plus 13, 34, plus 13, 47, and our 5th term here, plus 13 gets us 60. Okay? So we saw that first term, we're told A1 equals 8. We come down here and we see we're taking whatever term we got and we're adding 13 to find the next one. This is what we've got right here. I want to add to it to find the next term in our sequence. Drop down to B. Let's write an explicit formula for the sequence. Okay? So we know that A1 equals 8. And we know that D equals 13. We're adding 13 each time. Okay, now if we pull up our explicit formula, okay, so AN equals A1 plus N minus 1 times D. We'll look at that. We've got A1, we've got D. We're going to leave it in there. That's going to be whatever term number we want to find, and then there is the term value. We have AN equals 8 plus N minus 1 times 13. Okay, now the reason why I put the plus here is because sometimes our common difference might be subtraction, sometimes it might be addition. I like to put that plus there to tell me that we are going to be adding, it's going up. So even though we don't add here, we're multiplying a positive number each time. Okay, so that's why I keep the plus there. Not because we're adding, but because we have a positive number. Okay, now hopefully going over these 3 examples with arithmetic sequences and one with geometric sequences will help us be able to do the assignment on the back of these notes. Okay, in the next video we're going to look at more of our geometric sequences, also throw in an arithmetic sequence, and then you should hopefully be able to finish all of the assignment that goes with these notes. Okay, thank you for watching.